This project is on artificial intelligence in healthcare diagnosis, more specifically, vocal biomarkers. Here's our overview for our project. The history of artificial intelligence, or AI, has a long and varied past, with its roots going back centuries. Although it is difficult to pinpoint the exact moment AI began, the first recorded use of the term artificial intelligence dates back to 1956. Since then, AI has grown exponentially, and its reach now extends to nearly every area of our lives. AI was initially developed to solve complex problems that humans could not, such as playing chess. In the 1950s, computer scientists developed a program that could defeat the world's best human chess players. This success sparked a wave of interest in the potential of AI, leading to a steady increase in the number of research projects and applications involving AI. In the 1970s, AI began to be used for more practical applications, such as natural language processing, expert systems, and robotics. The development of expert systems, in particular, made it possible for machines to make decisions based on rules or a given set of data. Expert systems were used in a variety of contexts, including medical diagnosis, financial forecasting, and the management of complex systems. In the 1980s and 90s, AI began to be applied to even more practical problems, such as speech recognition and machine learning. During this time, AI began to move away from being simply a tool for problem solving and began to be used to automate processes. AI was also used to create expert advisors in decision-making systems, which could be used in a variety of contexts. Today, AI has grown even further with more sophisticated applications such as self-driving cars and facial recognition. AI is also being used for a variety of tasks, such as natural language processing, image recognition, and data analysis. AI is now used in a variety of industries and is expected to play even more of an important role in our lives in the future. The history of AI has been one of rapid growth and innovation. It is clear that AI has come a long way since its inception, and its potential is only just beginning to be realized. As AI continues to evolve and become more sophisticated, it will no doubt continue to change the way we interact with the world around us. The history of vocal biomarkers. A biomarker is a signature, a feature, or a combination of features from the audio signal of the voice that is associated with a clinical outcome and can be used to monitor patients, diagnose a condition, or grade the severity or the stages of a disease for drug development. The use of voice recordings to diagnose or monitor medical conditions dates back to the late 19th century. In the late 1800s, physicians began to use a phonocardiogram, a device that records the sound of a beating heart, to diagnose murmurs and other conditions. This early form of vocal biomarkers was used to detect abnormal heart sounds, helping physicians to diagnose and treat heart conditions. In the 1940s, doctors began to use oscilloscopes to measure the frequency and intensity of sound waves produced by the vocal cords. This technology allowed physicians to diagnose and monitor vocal cord disorders such as paralysis, polyps, and nodules. In the 1970s and 80s, vocal biomarkers were further advanced with the development of computer-based technology. This technology allowed for the automated analysis of vocal recordings, making it easier to detect abnormalities in vocal patterns. In the 1990s, voice recognition technology was developed, allowing computers to recognize and interpret speech patterns. This technology helped to identify voice patterns associated with certain medical conditions, such as Parkinson's disease and depression. Today, vocal biomarkers are being used to detect and diagnose a wide range of medical conditions. For example, voice recordings are used to monitor asthma and other respiratory diseases. detect sleep disorders, and diagnose medical conditions. Vocal biomarkers are a relatively new area of research within the field of speech science. There are defined as acoustic features that are related to a person's health or physiological state, such as their age, gender, or emotional state. By analyzing vocal biomarkers, researchers are able to gain insights into the person's underlying health and psychological states of a person. This can be used to aid in diagnosis, treatment, and even prevention of various diseases and disorders. Vocal biomarkers are based on the fact that a voice is a reflection of our physical and mental health. The voice contains information about the size and shape of our vocal tract, our muscle movements, and even our emotional state. By analyzing vocal biomarkers, researchers can gain insights into a person's health and state of mind.
I'm going to talk about artificial intelligence in respiratory diseases. How does voice biometric technology work? There are two steps, which is the extraction and the voice print comparison. The extraction is using a speech biometric technology to analyze a sample of a person's voice and produce mathematical representation of their voice. This stage is also known as voice enrollment if the system is listening to the person's voice for the first time. Voice print comparison to identify a match required for successful speaker verification or speaker identification. The extracted voice print is compared with other recorded voice prints. The spectrogram is the recording itself. So the spectrogram provides a more comprehensive examination of the acoustic, in which brightness denotes the wave's amplitude and the vertical and horizontal axes stand for the frequency and time respectively. A vocal biometric system builds a mathematical model using a set of floating point integers that describes the distinctive qualities of a person's voice based on the spectrogram analysis of the acoustic wave the person produces, to determine the ideal collection of numbers to represent the contours, dimensions, and motions of the voice organs of a person. Statistical and AI techniques are applied. A voice print is a representation of a voice in mathematics. It's interesting because using speech biometrics and AI, it's possible to identify a person's gender, age, height, and facial visualization. There is this application that uses voice biometrics to detect asthma in children, which is the Cough Analyzer app, developed by Cardiology University and University of Queensland. So it's used to detect respiratory diseases, which ensures early diagnosis and treatment of this type of respiratory illnesses. With machine learning algorithm, the app recognizes characteristics, features of coughs of 5 different diseases: asthma, pneumonia, croup, bronchitis, and lower respiratory tract disease. Asthma was the easiest for both the application and the panel to diagnose, with 97 and 91% accuracy. Pneumonia, 87, 85. Lower respiratory tract disease, 83, 82%. Croup, 85, 82%. Bronchitis, 84, 81%. So it's important because an early detection and continue monitoring is important in terms of detecting and helping treat these respiratory illnesses. There's also the use of the speech measure to detect pulmonary congestion. So it's another phone application, HAR-O. There are actually 3, HAR-O, Cardiomedical, and Yehuda. So speech measures were indicative of pulmonary congestion among patients with acute decompensated heart failure. There are 5 characteristics of the speech that they analyzed. So out of 1,484 recordings analyzed, the discharge was successfully identified as distinctly different from a baseline in 94% of the cases, and distinct differences from baseline were detected in all 5 speech measures. So meaning they could successfully detect the pulmonary congestion for future treatment. There is a frontier study that they diagram an holistic approach. So they start with cough recording, cough collecting, then experts analyze the cough to train and help classify the cough and help the AI machine learning to accurately classify according the characteristics of each respiratory disease. So new data is entered every time. So it's in a cloud storage, which allows for public large data sets. That is very important because the more information, the more the machine learning can be more accurate. So, and it's also important, the expert opinion. since it will help also train new doctors to identify different type of coughs as well. So the goal of the cough classification was to create an autonomous system that can categorize several aspects of coughs, including the severity, frequency, energy distribution, and whether they are wet or dry. So it was for early detection. For example, like COVID, like in the past pandemic, you can now detect COVID with a phone application and AI. So they submitted data to certain machine learning or deep learning algorithms, support machine learning, artificial neural network, convolutional neural network, and after extracting some pertinent patterns from the system's inputs and creating a feature vector or a matrix. Deep learning networks, on the other hand, rely on layers of artificial neural networks, whereas machine learning are nearly as always need structured data. As for future trends, voice metric recognition is getting more common, and there is an increase in the market size of speak recognition software. So it can be artificial and not artificial intelligence involved. So Amazon and Google have a venture capital, Avia. So they focus in bringing technology to the healthcare system. So they is a patient-focused speech system, which is installed in hospitals and senior living institutions so that they can be monitored and detect illnesses based on the voice recognition software. There are some ethic concerns, for example, gender and racial disparity in voice recognition. So Nature did a study and they noticed that within genders for women was more accurate just because there were more women recordings, and also within the race for white women was higher compared to Asian, Latinx, or Black, for example. So the data show that disparities in gender subgroups are higher, while differences in overall racial groups are minor. They found that racial discrepancies in speech biometrics are not largely caused by differences in voice quality, but rather a technical issue with the feature extraction. On the other side, the fundamental qualities of the voice and feature extraction technology are primarily responsible for gender differences. The findings shows that learning the whole speech characteristics for voice biometrics is to some extent constrained by neural network-based feature extraction. So what this means is that the machine learning needs more diversity to recognize the slight difference within gender and race. Because I said earlier, there was more women recorded, especially white women, so that's why their accuracy is higher compared to male, and of course, minority groups that are not much involved in the recordings and in the machine learning. So again, with the future trends, Pfizer is also involved in voice recognition and respiratory systems study. They are developing it. They are investing in voice recognition software technology for very different type of diseases, which my group we also discuss. So also Spotify depends on your mood. It has a assistant feature like Hey Spotify, and it will catch on the music based on your mood in your voice in general, how you feel, and it will suggest music.
Throughout the next few slides, I'll go over research studies that used AI technology in analyzing complex medical data to identify, measure, and track decline cognitive function. This data is then used in developing biomarkers for aging and aging-related diseases such as Alzheimer's and dementia. In this first study, researchers examined the power of speech to predict cognitive impairment. And given that elderly may have limited mobility, this study looked at AI technology and AI biomarkers to enable remote automated features to assess cognitive functions using the telephone or the internet. Over a span of 4 years, researchers used an in-home computer automated platforms to collect linguistic and non-linguistic data to provide useful information for cognitive assessment. The results that IVR technology, which stands for Interactive Voice Response, which measures voice frequency, speaking rate, and speech flow. The study resulted that audio testing is appropriate and reliable for the diagnosis of cognitive impairment. The second study, researchers worked on identifying and choosing effective and personalized strategies to prevent or slow the process of Alzheimer's disease, using deep learning procedures combined with MRI imaging, neuropsychological, and APO4 genetic data to simultaneously predict mild cognitive impairment and Alzheimer's and the diagnosis of Alzheimer's. The algorithm developed was able to distinguish mild cognitive impairment patients who are at risk of developing Alzheimer's within 3 years from those patients with stable cognitive function over the same period. Once again, the results that the algorithm provided was 100% accurate when classifying patient with AD from the healthy controls. And the third study, researchers worked on developing AI-based computer-aided tools, CAD, to improve doctors' performance in assessing and detecting early signs of cognitive impairment. Using deep learning, CAD tools, and the MONA AI framework, they were able to develop accurate assessment tools. MONA AI is an open source PyTorch-based framework for deep learning that was developed to standardize practice in the medical imaging field. The deep learning model yielded 80% accuracy and 60% specificity, which indicate good performance. Once again, AI it was able in standardizing workflow using CAD tools, which will improve clinical management policies. And finally, AI and AI computer-based diagnosis tools are very useful in understanding and developing AI products in the healthcare system. Voice features and voice biomarkers are reproducible, non-invasive tools for early diagnosis and detection of dementia and cognitive functions. Some companies that are investing in reproducible AI biomarkers technology and drug development include BioAge and in silico companies. The adoption of best practice for neuroimaging data analysis and voice biomarker is a step forward toward the efficacy and the safety of CAD and AI products in the healthcare system.
I'm going to talk about the use of vocal biomarkers in cardiovascular disease. Cardiovascular disease is not just a US problem, it's a worldwide problem. In the US, someone has a heart attack every 40 seconds, and we lose roughly 700,000 people each year to heart disease. Worldwide, 17.9 million people die each year from heart disease, and of those, 4 to 5 are from heart attacks and stroke. We're going to talk about 3 studies that deal with vocal biomarkers and cardiovascular disease. The largest study is from 2020 and took place in Israel. One of the benefits of socialized medicine is you can collect a whole bunch of data on people. This study looked at 10,500 patients who had been diagnosed with congenital heart disease. The way their heart disease was managed is that they would call into a call center and speak with a nurse to see how they were doing. What happened was 20 seconds of each call was recorded, and then it was analyzed for various acoustic features like pitch, jitter, shimmer, and loudness. They ended up with over 223 acoustic features, and from that, machine learning developed a cardiovascular biomarker. The model showed that each standard deviation increase of the biomarker was associated with a significant 48% elevated risk of death. When that was adjusted to known predictors of poor survival, each standard deviation still showed a significant 32% elevated risk of death. So there was something in the voice that they did not see with other predictors. Patients in the high biomarker quadrant were also at more risk of hospitalization. The second study looked at cardiovascular disease and plaque buildup. It was published in 2022, and the lead author was Dr. Singsara at the Mayo Clinic. It looked at 108 patients who had been referred for a coronary angiogram. That's when dye is injected into blood vessels using a catheter, and then x-rays known as angiograms are taken of those vessels. If need be, a balloon or a stent can also be passed through the catheter to keep the blood vessel open. Vocal samples were taken of the 108 patients. An algorithm analyzed participants' voice samples, identifying more than 80 voice recording features such as frequency, amplitude, pitch, and cadence. Researchers then took 6 features highly correlated with coronary artery disease and combined them to form a single score. 1/3 of patients in the study received a high score and 2/3 a low score. People with a high vocal biomarker score were 2.6 times more likely to suffer major problems associated with coronary artery disease and 3 times more likely to show evidence of plaque buildup. Specifically, 58.3% of patients with a high vocal biomarker score went to the hospital due to chest pain or acute coronary syndrome. This is almost 30% higher than the 30.6% of low vocal biomarker score patients who went to the hospital. Remember, all of these patients had symptoms enough that they were referred for a cardiac angiogram. Researchers hypothesized that the link between voice and cardiac health has to do with the autonomic nervous system. This is the nervous system that regulates involuntary physiological processes such as heart rate, blood pressure, respiration, which is used in voice, and digestion, but nobody knows for sure. The final study looked at stroke. Its lead author was Dr. Park, and it was published in 2022. Abnormal voice may identify those who are at risk of post-stroke aspiration. Aspiration is when you're eating and your food goes into your lungs rather than into your stomach. A stroke may cause a swallowing disorder known as dysphagia. If it's not identified and managed, it can lead to poor nutrition, pneumonia, and dehydration. Aspiration is a common problem for people with dysphagia. The study aimed to determine whether machine learning algorithms with voice recorded via mobile device can accurately classify those with dysphagia at risk of tube feeding and post-stroke aspiration pneumonia and be used as a digital biomarker. Remember, if they were having trouble swallowing, that means they're having trouble eating, so they might need a tube to help them get their nutrition. Similarly, if they're having trouble with their swallowing, they're more likely to have food be aspirated into their lungs and have develop pneumonia. A total of 449 vocal samples were obtained, with 234 patients requiring tube feedings and 113 showing high risk of respiratory complications. In both cases, voice features proved to be the strongest contributing factor in those models. They may be considered a viable digital biomarker in those at risk of respiratory complications related to post-stroke dysphagia. What this means is they can be managed better. They may be referred to occupational therapy sooner, or they just may have more close nursing. When we talk about the relevant benefits, cost, and even risk of this technology, the hugest benefit that cannot be understated is accessibility. Anybody with a smartphone has access to this technology. We're not just talking healthcare workers, we're talking about everyday people. It has great implications not only for diagnosis, but also for disease management. it will be a game changer for both rural and global medicine, where you're not likely to have specialized providers everywhere, or you're not likely to have expensive equipment. The costs are actually really minimal, both in development and when you actually look at buying the actual technology. Researchers say that the costs are extremely low compared to drug development and medical devices, with even $10,000 in funding making a huge difference. The cost to actually purchase the applications is likely to be low, and because that's low, the likelihood that insurance companies are going to reimburse you for that is high. Where things are a little bit more muddled are in the ethical arena. We don't know how this is all going to work out, and that's still being decided. The Israeli protocol did a really good job. They kept the data non-identifiable, and they de-identified it using strict pseudonymization methods. Only specific voice elements rather than verbal recordings were analyzed, and the patients could only be de-identified with a special key that was not given to the researchers. But there are also ethical concerns of being diagnosed without knowing. If you call for a job, if you're applying for insurance, be it life or medical, can you be denied and you'll not know why? If you call a hospital system and they can analyze you and determine that you're at risk of cancer or of stroke and they don't tell you, do they have medico-legal liability? And then, of course, what happens to your voice sample and how is that data used? What we do know is the future of vocal biomarkers is huge. The National Institute of Health has already invested $14 million to develop a vocal biomarker database. Their goal is 30,000 voice samples. That's quite a small number when we look what Sonda Health has already achieved. They have 1.2 million samples that they've collected on over 4 different continents. They've already developed a application for managing asthma as well as depression, and they raised $19.5 million in funding just this month. That is not their first round of funding, it is actually one of many. Belkacem Health is the company that came out of the Israeli study who has the cardiovascular biomarker. They are working with universities and health systems around the world, including Mayo and Geisinger, which is a large chain of hospitals up in the Northeast. Brand estimates that this is going to be a $5 billion industry by 2030. What does that mean? It's highly likely that you will see vocal biomarkers in your life, at your doctor's, possibly on your own phone in the near future. Thank you very much.